These are video notes for section 3.5 in algebra. We're going to look at parallel and perpendicular lines. So you probably saw parallel lines in pre-algebra when you were talking about systems and you talked about how they never touched, and that's because they had the same slope, but they had different y-intercepts. So now what we have perpendicular lines, and those meet at a 90-degree angle, but we're not going to measure that like we would with a compass. We're going to look at the slopes. So here I can see that I have a slope of 3, and the other has a slope of -1/3. So we say that the slopes are opposite reciprocals. So that means one's positive, one's negative. And we can also say that the perpendicular, so here's the symbol for perpendicular slopes, have a product of -1. So if I took 3 times -1/3, the product would be -1. Okay, so in these first examples, we're just saying if they're parallel, perpendicular, or neither. So all we're going to do is look at the slopes. So in this first one, the slopes are already figured out. I've got a slope of 1 and a slope of, slope of 2 and a slope of 1/2. And when I multiply those, I get +1. So that would be neither. So those slopes are neither parallel nor perpendicular. Now this next one, 3y equals -4x plus 6, it's in the right order, but our y gets multiplied by 3, so we have to divide by 3. So -4/3 x plus 2, and then we're looking at this slope, -3/4 x minus 5. And I can tell that those have the numbers are reciprocals. We've got 4/3 and 3/4, but since they're both negative, they would multiply to make +1, so this is neither. Moving on, and I changed this during class to be a 10, so it just works out to be a less weird number. This first one has a slope of -5x. We could put a +0 on it, but that doesn't matter when we're comparing our slopes. On the next one, we're going to rewrite in slope-intercept form. I'm going to subtract 25x on each side. So that's going to get me in the right order. 5y equals -25x plus 10. And when I divide both sides by 5, we're going to get y equals -5x plus 2. So I've got a -5x here and a -5x here. I guess we could put that +0 back and just point out that the slopes are the same, but the y-intercepts are different. That would make parallel lines. Now, this is the one special case, and it's only one, and it's when you're given an equation or two equations of lines, 1, 2, 3, 4, 5, and one line has an equation of x equals 4. So that's VUX. That's the vertical line. Every point on that line has an x value of 4. So that's 4, 0, maybe 4, -4, 4, 2. They all have an x value of 4. And then y equals 4. 1, 2, 3, 4. Everything that's HOY, we use HOY to remember that's a horizontal line, the slope is 0, and everything here has a y value of 4. So 0, 4, this might be -3, 4, this could be +3, 4. Because one slope, we have a slope of 0 and a slope. You can't multiply 0 times undefined. So you just have to know that one is horizontal and one is vertical. So by definition and on a graph together, those will be perpendicular lines. Okay, now we're going to do some graphing, and we're going to use slope-intercept and point-slope form and graph these and then write their equations. So example 1 says, given the line y equals negative 2x plus 4, write the equation of the line that is parallel and goes through 3, 4 using slope-intercept form. Okay, so I'll graph my given equation, negative 2x plus 4. So I'll start at 4 and go down 2 and over 1. I'm going to do that till I run out of room on my graph. And then I'm going to do my next line, and the next one goes through 3, 4. So over 3. And now, if it didn't tell you explicitly how they would want you to do it, you could just start graphing and find your answer. It's telling us to use slope-intercept form. So y equals mx plus b. And my parallel, that's the symbol for parallel. My parallel slope is going to be the same. So my parallel slope is negative 2, and I'm going through 3, 4. So I'm going to put all of those values in. My m is negative 2. My x is 3. Plus b, so 4 equals negative 6 plus b, and when I add 6, I'm getting 10 equals b, so my equation will be negative 2x plus 10. Okay, so if I start at 10 and I go down 2 and over 1, down 2 over 1, I'm hitting that point that I wanted to go through. Down 2 over 1, down 2 over 1. And I'm going to connect with my, my straight line tool. Okay. Now we're going to use, they're telling us to use point slope form. And we're going to write the equation of a line that is perpendicular to this given line. So let's start with our given line. 1/8 x plus 2. So I'm going to start at 2, and I'm going to go up 1 and over 8, and then I'm going to go down 1 and back 8 to cover my whole graph. Okay, so not a very steep line. So I'm doing perpendicular slope. If my given slope is 1/8, my perpendicular slope has to be the reciprocal of 1/8, which will be 8, and I need my slope, since this one is positive, I need my slope to be negative 8. And then I'm going to go through 1, negative 5. So my formula is y minus y1 equals m times x minus x1. So y minus negative 5. Whoops, let's make that. Instead of doing y minus negative 5, we're just going to write that as y plus 5. Equals my slope, negative 8 times x minus, substituting 1 in for x. So y plus 5 equals negative 8x. Negative 8 times negative 1 would be plus 8. And when we move the 5 over, we're going to subtract. So y equals negative 8x plus 3. And I wanted to go through 1, negative 5. Okay, so my slope goes down 8 and over 1. I can't even do that on this graph. So if I go up 8, 1, 2, 3, 4, 5, 6, 7, 8, and over 1, I'm touching that y-intercept of 3, and that's what I was supposed to get based on my equation. Whoops. Let's get that straight line. I'm going to fix that. I'm being a perfectionist. Turn that off. And there we go. Okay. Next one, we're going to use slope-intercept form to write the equation of a line that passes through 4, 1 and is perpendicular to that given line. So my given line has 4y equals 8x minus 12. And even though we're in the right order, y and an equals and an x and a number, I'm going to divide both sides. Whoops. I'm going to divide both sides, or every term I should say, by 4 to get y alone. So y equals 2x minus 3. So I'm going to graph that one first. Start at -3. I'm going up 2 and over 1, up 2 and over 1, up 2 and over 1. Let's fix that. Now we're going to do a perpendicular line. So my perpendicular slope, since my given slope is 2, it's positive 2, my perpendicular slope is going to be -1/2. And I'm going through 4, 1, and we'll use y equals mx plus b. So I can put my y value from the order pair is 1. My perpendicular slope is -1/2. And the x value is 4. And we're solving for b. So 1 equals -1/2 times 4 is -2 plus b. And I'll add 2, which will give me 3 is b. So my equation is -1/2 x plus 3. So here's my 3, and I'm going to go down 1 and over 2. 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 And I can see that the point 4, 1 that they wanted is on that line. And so there's my equation. It's going through that spot. And we're good. This is our last example. We're going to graph y equals 3x. And we're going to find a line parallel to it going through -4, 4 using point slope. So my y equals 3x. I can't see a y-intercept, so I can put +0 on it. So I'll start at the origin and go up 3 and over 1, up 3 over 1. It's nice that these graphs count by 3s. Down 3 and back 1, down 3 and back 1. Using my straight line tool to make a straight line. Okay, now I'm going to make a parallel line. So my slope is going to be 3. And we're using point slope form. We're going through -4, 4. So I'll use my formula. Y minus y1 equals m times x minus x1. So y minus +4 equals my slope, which is 3, times x minus, and that -4 turns into +4 when it gets subtracted. So y minus 4 equals 3x plus 12. And I just have to move that 4 over with addition. So that gives me y equals 3x plus 16. And there's my 16 way at the top of that graph. And if I was doing this without knowing the point, I'm just going down 3 and back 1. Down 1, 2, 3, back 1. I'm going to stretch across the whole graph. And I'm going to connect my lines, or connect my dots. Let's try that again. Shoot, let's try that one more time. I'm having a tough time with this today. Connect those dots with a straight line. And the point I wanted to go through was negative 4, 4. And there it is. All right, so again, to wrap up, parallel slopes. This was old news. Perpendicular slopes. Their product has to be the product is -1. So let's say you have a slope of 2/5. The perpendicular slope would be -5/2, because when you multiply that, you're going to get -10/10, which would give you -1.